Welcome back, students. Now we will continue the multiple choice questions related to the equilibrium. So let us start with question number 22. An aqueous solution of 0.1 molar ammonium chloride has a pH very close to 2. So here ammonium chloride, when it gets hydrolyzed, means we are getting ammonium hydroxide plus which one? HCl. This is a strong acid and this is a weak base. Here, according to the general concept, pH is equal to 7 minus half of pKb plus log base 10 of concentration of that. But here, only the concentration of ammonium chloride is given, but not the value of Kb or pKb. Therefore, we can't apply this one. But totally we will decide the solution is going to be what in nature? Acidic in nature, because it is a combination of which and which? Weak base and then the strong acid, means it is having the more of what strength? Acidic strength. If higher the acidic strength means the pH value is what? Less than 7. So according to that, the less than 7 is going to be what? It is 5.1. Suppose if what is given, the concentration, either the Kb or pKb is given, means then you have to apply the formula pH is equal to 7 minus half of pKb plus log base 10 of which one? C. As if we didn't have that one, just it is a salt of which and which? Strong acid and then the weak base. Therefore, the solution is going to be strictly what in nature? Acidic. If acidic is the case, the pH value is always going to be what? Less than how much? 7, that is equal to 5.1. Okay, let's have the next one. For the reaction, what's that? N2 plus O2 gives rise to 2NO. The equilibrium constant is K1. Then the equilibrium constant is K2 for the reaction 2NO plus O2 gives rise to 2NO2. Then what is K for the reaction? NO2 gives rise to half N2 plus half O2. Sorry, O2 only. Okay. Let's have N2 plus O2 gives rise to what? 2NO. Here this is K1. Then the second one is, what is that? 2NO plus O2 gives rise to what? I think 2NO2. Here the equilibrium constant is going to be what? K2. But here we have to find out the value of the same equilibrium constant for the reaction. What is that? NO2 gives rise to half N2 plus what? O2. First, when I add up these two, can I cancel these two here? Yes. Now I left with 2O2. N2 plus 2O2 gives rise to what? 2 times of NO2. Here, this K is equal to actually K1 into K2. Why? Because it is the sum of these two, means it is the individual equilibrium constant is always equal to the what? The product of that if I calculate the net equilibrium constant for the reaction when they get added. Okay, that is K total is equal to K1 into K2 into so on up to what? Kn. It depends upon the number of steps involved. But here we need the reaction for that. That is, for this reaction it is NO2 gives rise to what? Half N2 plus O2. Means this to this is reversed the equation. We have reversed the equation. And this is divided by 2. That means the number of moles has been reduced to half. Then what is that? If the reaction gets reversed and the number of moles gets changed, means Kc for the backward reaction is equal to 1 upon Kc for the forward reaction to the power of n. What is the n here? Number of moles has been reduced. Therefore, Kc is equal to 1 upon K. K means here to the power of 1 by 2. That is equal to 1 upon. What is K actually? It is K1 into K2 to the power of what? 1 by 2. Therefore, this is the 1. Means first we have added these two to get the value of K. In that K, we are getting the equation as N2 plus 2O2 gives rise to what? 2N2. But we need the equilibrium constant for what reaction? NO2 gives rise to half N2 plus O2. From these two, what we are deciding? First, the reverse reaction gets reversed and the number of moles has been reduced. If it is reduced, means to the power of n. Therefore, it is equal to what? 1 by 2. Therefore, the option with respect to that is going to be the what? D. Okay. Let's move on to the 24th. So here, the decreasing order of the strength of the bases. What are the bases here? OH minus, NH2 minus, acetylidion, CH, triple bond C minus, and then the CH. So here, OH minus is next NH2 minus, then CH triple bond C minus, then followed by the last one is what? CH3. First, what these are? They are the bases, I think. Then what is the conjugate acid of that? Conjugate acids are, add H plus to this, what happens here? It becomes H2O, it becomes NH3 here, it becomes CH, triple bond CH, and then it becomes ethane. As we know that hydrocarbons are almost neutral, and they are going to be the what? Least acidic. What acidic? They are least acidic. If they are least acidic, means its conjugate base is going to be the what basic? More basic. So means among the 4 different conjugate bases, OH minus, NH2 minus, CH triple bond C minus, and then the ethyl carbene ion, which is going to be the more basic, it is the CH3 CH2 minus, because its conjugate acid, that is called ethane, is perfectly neutral, or sometimes it is going to be the least acidic. Means which is the more basic here? It is first this. According to this, this is the one. So here on that basis, what we can decide? H2O is considered to be the what? More acidic. What acidic? Water is going to be the more acidic. Then we will have the what? Acetylide is going to be the next acidic, followed by the last one is going to be the what? It is the NH3. Just instead of moving for all the 4 different options here, just you have to know that the conjugate acid of that one, that is CH3 CH2 minus, is going to be the ethane. We know that hydrocarbons are neutral. If they are neutral, means it is almost less acidic. If it is less acidic, means it is going to be the what? More. Its conjugate base is going to be the more base. Okay, so that is 24A. The pH of which one? 0.1 molar of sodium bisulfide is K1 and K2 for H2 is what that? K1 and then K2 for the H2S is going to be what and what? 1.3 10 to the power of minus 7 and 7.1 10 to the power of minus 15 respectively. So here H2S gets ionized to form what is that? It is HS minus by the loss of 1 proton. This is also converted as S2 minus by the loss of another proton. Here the dissociation constant for with respect to this is K1, and here it is with respect to this is, means here we are finding the, which is that pH of sodium bisulfide, in that this is Na plus and this is HS minus. Usually this doesn't have the interaction with the pH because it is neither a H plus or the OH minus. Now, as it is the intermediate between them, then the pH of these type of physics is given by directly the formula pKa1 plus pKa2. Half of pKa1 and then pKa2. So let us have pKa1 first. It is negative log of Ka1, that is equal to negative log of, what is K1 here? K1 is going to be the 1.3 into 10 to the power of minus 7, that is equal to 7 minus log 1.3, that is equal to 7 minus 0. So we know that first log 1 is 0, log 2 is 0.3. Log 1 is 0 and log this one is 2 is 0.3. But we are to know the value of log 1.3. 1.3 is in here. I have mentioned in the previous, for every 0.1 decimal places, it is having 0.03. 0.03 into 3 is equal to 0.09. Means it is 0.09, that becomes 6.91. What is this? The pKa1. Similarly, we will have the what? pKa2. What is that pKa2 here? Negative log of Ka2. What is Ka2 here? Negative log of, what is Ka2 then? 7.1 into 10 to the power of minus 15. That is equal to 15 minus log 7.1, I think. That is equal to 15 minus. What is log 7 and what is log 8? First, you have to know the values of those two first. Okay. What is log 7? Log 7 and then log 8. What is the value of log 7? Log 7 is found to be the 0.78, I think. So here it is found to be the 0.85. Sorry, it is 0.85. Here it is 0.90. That is log 7 and log 8. But we need a log 7.1. So it is very nearest to that. So as the difference is found to be nearly, what we can mention it is nearly 8.5, and here it is going to be the 0.9. So here it is 7.1 is approximately 8.6, nearly approximate. I don't have the exactness. 0.86. That is equal to 14.14. 14.14. So here half of, what's that here? 6.91 plus 14.14. That is equal to, so half of 20. 20 plus 21, 21.05 I think. So that is equal to nearly 10.51 or 52 like this. It is approximately this. So to solve these type of numericals, you must be very perfect with respect to the log from starting from 1 to log 10, because they didn't provide any calculators or didn't provide any log table. Suppose if they are given, it is no problem, but you should have the concept of the fractions of that particular log tables. Okay, based on that we are getting the final answer is going to be what? 10 point how much? 52. Okay. Next is stannous chloride and mercurous chloride cannot exist in the solution. Why? Why the solution of which and which? Stannous and mercuric, sorry, HgCl2 is called as mercuries. Cannot exist in the solution. Why? Because we know that we have already discussed in the redox reaction concept. So here, if one substance is found to be the oxidizing agent, then another must be an example for a what? Reducing agent. Here, stannous chloride plus HgCl2. So here it can be converted into SnCl4 plus Hg2Cl2. Means here it is plus 2, here it is plus 1. Here it is plus 2, here it is plus 4. Or sometimes that mercurous chloride also combines with SnCl2 to form directly SnCl4 plus Hg, 2 times of Hg. Here it is 0, here it is plus 1, here it is plus 2, here it is plus 4. So the net reaction is, I can cancel these two. Sorry, not this one. Hg2Cl2. Therefore, the net concept is SnCl2 plus HgCl2 gives rise to what? SnCl4 plus Hg. Means here it is 0, here it is plus 2, here it is plus 2, here it is plus 4. Means this is called as oxidation and this is called as reduction. That is why it is called as redox. Means we can't have the coexistence of which and which? Stannous chloride and then the mercuric chloride, because one is acting as an oxidizing agent, another is acting as a what? Reducing agent, and that is due to the presence of which one? The what change? The redox change. Okay. Let's move on to the next 27th. Which can be explained as applications of Le-Chatelier's principle. What are the? Whether the transportation of oxygen by the which one? Hemoglobin in the blood, removal of carbon dioxide from the tissues by the blood, tooth decay due to the use of the sweet substances, all of this. So here, all these are the very best examples related to the which principle? Le-Chatelier's principle. As if we know that oxygen combines with the what? Hemoglobin that has been present in the blood to form oxyhemoglobin, which enter into the tissues and through the lungs. So reversing back, the oxygen came out. It is a reversible reaction. As the pressure gets decreases, means the oxygen comes out. Means it is a principle of which one? Le-Chatelier's. Because that excess of oxygen that has been obtained is used for the combustion of the food that we have taken in the form of carbon dioxide. Therefore, it is an example for a what? Le-Chatelier. It depends upon the pressure of the oxygen that has been present. If the pressure inside the lungs is found to be the less, means it is moving towards the right side. If it is found to be the more, means it is moving towards the what? Left side. Okay. Similarly, carbon dioxide, removal of carbon dioxide from tissues by the blood. So here the same thing. Carbon dioxide also combines with the hemoglobin, that is due to the combustion of the food that we have taken. It forms carboxyhemoglobin. Carboxyhemoglobin. So here that is also removed out because it is called as the expulsion, or it is also called as the exhalation of the which dioxide? Carbon dioxide. Therefore, that is also an example with respect to which one? Le-Chatelier's principle. The tooth decay due to the use of the sweet substances. So usually CA5PO4 thrice with OH. This is called as hydroxyapatite. Hydroxyapatite. It is called as tooth enamel, which protects the teeth actually. It protects what? The enamel that has been present on the teeth. Suppose this is called as demineralization. So here it gets decomposed to form calcium ion and the phosphate ion with the removal of OH minus. And the reverse of that one is called as remineralization. Remineralization. M-I-N-E. Mineralization. Suppose if we take the sweet inside that, what happens here? So excess of sweet can releases the what? H plus. What happens when the H plus enter into the system? So here this H plus removed in the form of, that combines with the OH minus in the form of which one? H2O. Means removal of OH minus shifts the equilibrium towards the what? Means there is a remineralization or demineralization, which is reversed to that of which one? The remineralization. That is why the decay is due to the use of the which one? Excess of the sweet substances. Because excess of the sweet substances that we are taking, what it will do? It produces the what ions? H plus ions. It removes the what ions? OH minus, such that it favors the backward reaction that is called as remineralization. Again, we have to put the tooth enamel in the form of hydroxy which one? Apatite. Therefore, all these are the best examples related to the which one? Lee-Chatelier's principle. Okay. Let's move on to question number 28. The solubility product of which one? Magnesium hydroxide at a particular temperature, at ordinary temperature, is found to be how much? 1.96 into 10 to the power of minus 11. Then, what is the pH of the saturated solution of magnesium hydroxide will be? Here Ksp is given. Now we have to find out the value of which one? Solubility. pH. pH means we need the H plus or the OH minus. As magnesium hydroxide, we know that it is an example for a AB2 type. If this be the case, Ksp is equal to, can I directly write that as 4s cube? That is the relation between solubility and solubility product for what type of electrolyte? AB2. So here, S is equal to directly cube root of Ksp divided by 4, that is equal to cube root of, what is Ksp there? 1.96 into 10 to the power of minus 11 divided by 4. I will make this as 20 into 10 to the power of minus 12. So that is equal to cube root of 5 into 10 to the power of minus, cube root of 5 into 10 to the power of minus 3, I think, minus 4 3s are 12. 12 means, so here it is first, cube root of that is equal to 4 molar. Now what is the cube root of 5 here? That's very important here. Cube root of 5 is nothing but 5 to the power of what? 1 by 3, taking the log on both sides, log to that, log 5. 1 by 3 into log 5 is actually 0.7. Log 5 is actually, log 4 is 0.60, log 5 is how much? 0.7. That is equal to 0.2, the 2333, I think, 0.2233. Therefore, what is antilog of that? 0.2333. So here, log 1 is 0, log 2 is 0.3. Where this 0.233 comes out here, it is nearly 0.75 or it may be the 0.78, whatever it may be. Means it is 1.75. The root of 5 is found to be the what? 1.75. That is equal to 1.75 into 10 to the power of minus 4 in terms of which one? Molar. So here OH minus is nothing but, this solubility is indirectly called as molar concentration, because solubility is the amount of the substance present per how much? 1 dm cube of the solution, which is indirectly called as what? Molar concentration, called as C. Here it is NC alpha. N is how many OH minus are there here? 2. What's the concentration? 1.75 into 10 to the power of minus 4. Not any time given means alpha is equal to 1. Without any this one, if this be the case, alpha is equal to 1 because it undergo complete ionization. That is equal to 3.75 into 10 to the power of 3.5, I think, sorry. 3.5 into 10 to the power of minus 4. What is this? OH minus. What is POH? I will directly move now. 4 minus log 3.5. 4 minus 0. Log 3 is what? 0.48. Log 4 is what? 0.6. What is log 3.5? Can I say it is intermediate between them? 0. The difference is actually 0.12. 12 means here it is found to be the 0.4. That is equal to Therefore, it is equal to 3.46. What is this 3.46? It is the pOH, not the pH. Therefore, what is pH? 14 minus that. That is equal to 10.54. What is 10.54 nearest equal to? These type of numericals are possible, or we can solve if and only if we are very familiar with respect to the log from 1 to 10 and the reverse of that one, that is called as antilogs. Okay, until and unless we can't solve these type of problems. Okay, so that is about the 28th question, that is A. Next is the hydrogen ion concentration. Which one? Of hydrogen ion concentration in mole per liter in a solution of pH is equal to how much? 5.4 will be. So directly we will move on to that. H plus is equal to antilog of minus pH. It is a direct expression. Antilog of minus 5.4. Antilog of, we know that negative antilogs cannot be obtained. What we have to do? Add this number 1 and make into a bar. Adding this one means it becomes 6 bar, and the fraction has to be subtracted from 1. What is 1 minus 0.4? It's 0.6. What is antilog of 0.6? Log 4 is 0.6. Therefore, what is antilog of 0.6? It's 4. Very simple. Okay. Therefore, it is 4 into 10 to the power of minus 6 molar. What is the nearest value here? It is 3.98 into 10 to the power of minus 6. Here, direct formula is H plus concentration is always equal to the antilog of negative pH. Negative pH means negative 5.4. But we can't have the what formula? Antilog for the negative. What we have to do? For this whole number, add 1 and then put as a bar. Therefore, 5 becomes what? 6, and minus 5 becomes what? 6 bar. And the fraction has to be subtracted from which one? 1. Therefore, it is 1 minus 0.4, that is equal to 0.6. What is antilog of 6? That is equal to 4. Therefore, 4 into 10 to the power of what? Minus 6. Okay. Next. When how much ml? 200 ml of aqueous solution of HCl is mixed with 300 ml of what? Aqueous solution of sodium hydroxide, its pH is also 12 actually. Then what is the pH of that particular resulting solution? So without moving into detail, just we will have the. So here, what is HCl concentration actually? Is nothing but H plus concentration. Can I directly write that as 10 to the power of minus 2 molar? Why? Because pH is what? 2. pH 2 means 10 to, what is this one? H plus is 10 to the power of minus 2. NaOH concentration is indirectly called as OH minus concentration. pH 12 means, first, pH 12 means pOH is 2. If pOH is 2 means, again, OH minus is also 2. Means, both have the same concentration, I think. Here we are having the 200 ml of 10 to the power of minus 2. Here we are having 300 ml of which one? 10 raised to minus. The resultant is what? Whether HCl is in excess or NaOH is in excess. As the concentration is same, but here 200 ml of HCl and 300 ml of which one? NaOH. Therefore, we are having more of what? NaOH. More than NaOH means the solution is basic. Solution is basic means it is greater than 7. Greater than 7 means it is without solving that. Okay, how? First we have calculated the concentrations of both the HCl and then NaOH. So their concentrations are found to be same. But their volumes with respect to HCl is found to be 200 and with respect to NaOH it is found to be the 3. Therefore 300. Therefore which is in excess? NaOH is in excess. If NaOH is in excess means it is basic. Basic means it is found to be the 11.3. So how to get this? OH minus left for 500 ml. Why I am writing that as 500 ml? Because it is 200 plus 300. 200 plus 300. So as usual we know that normality into volume by 1000. What's the normality here? 10 to the power of minus 2 into NaOH is 300 divided by 1000 minus 10 to the power of minus 2 into 200 divided by 1000. Or if I simplify that, it becomes, I think 10 to the power of minus 2 divided by 1000 is compulsory, and the difference of that one is going to be the 100. Therefore it is equal to these two cancels. It is equal to 10 to the power of minus 3. What's that? 10 to the power of minus 3 for how much? 500. Therefore, what is OH minus for 1000 cm cube? What is 1000 cm cube? It is 1 dm cube. Can you say it is double of that? 2 10 to the power of minus 3. 2 into 10 to the power of minus 3. What is pOH? 3 minus log 2 directly. 3 minus 0. What is log 2? 0.3010. Therefore, it is equal to 2.7. If pOH is 2.7 means it is 14 minus that. 14 minus this means it is 11.3. So that is the detailed calculation. But according to the concept, both the concentrations are same. NaOH volume is more compared to that of HCl. Therefore, the solution is more basic. If the solution is more basic, means readily we are getting the answer in the form of 11.3. That is basic. Okay. Next. Liquid ammonia ionizes to a slight extent. At minus 50 degrees Celsius, its self-ionization constant, that is KNH3, is equal to NH4 plus into OH minus is 10 to the power of minus 30. Therefore, how many amide ions are present per how much? 1 cm cube of the pure liquid. So this can be obtained if you know the concept of H2O plus H2O gives rise to what? H3O plus and then what minus? OH minus. This is called self-ionization of water. So here Kw is equal to H3O plus concentration into OH minus concentration. For neutral, these two are equal actually. Well, for a pure water, these two are equal. The same case is NH3 gets self-ionized with another molecule of this one to form ammonium ion and then the amide ion. Okay. So here K of ammonia is equal to what into what? It is given as NH3 into NH3. For pure ammonia, these two are equal. These two are equal. Therefore, can I mention directly in the form of NH2 minus whole square? Why? Because for a pure water, H3O plus concentration is equal to OH minus, means for pure ammonia, ammonium ion concentration is exactly equal to NH2. Therefore, NH2 minus into NH2 minus is found to be what? Therefore, what is NH2 minus root of KNH3? What is root of KNH3? Root of 10 to the power of what? Minus 30. That is equal to 10 to the power of minus 15 in terms of molar. What's the meaning of molar? It is mole per dm cube. Mole per how much? Dm cube. That is equal to 6.022 into 10 to the power of 23 into 10 to the power of minus 15 mole. Sorry, ions per dm cube. Dm cube means 1000 cm cube. Because how to convert mole to particles into respective what number? Avogadro number. Therefore, 6 into 10 to the power of 23 into 10 to the power of minus 15 ions per how much? Dm cube. But here, not the dm cube, but only the what? Cm cube has mentioned. Therefore, 6 into 10 to the power of 23 into 10 to the power of minus 15 divided by 1000 ions per. See, for 1000 it is that much. For 1 cm cube means it is divided by 1000. On simplification, I think it is 20. 6 into 10 to the power of 5 ions per cc. 6 into 10 to the power of 5 ions per cc. So that is the case of ionization of water or ionic product of water, but here it is called as ionization of ammonia. How the ammonia gets self-ionized? Ammonia, one molecule of ammonia acts as a solute and another molecule of ammonia is acting as a solvent. It gets self-ionized to form ammonium ion and then the amide ion. For a pure ammonia, these two concentrations are always equal. On that basis, we are getting this expression. Okay. So 31B. Next, in that which solution? Saturated solution of the sparingly soluble strong electrolyte. What is that? Silver iodate. AgIO3 is called as silver iodate and the molecular mass is directly given as how much? 283. The equilibrium sets in that as AgIO3 gives rise to Ag plus plus IO3 minus. If the solubility product of AgIO3 at a given temperature is found to be how much? 1 into 10 to the power of minus 8. Then what is the mass of which one? silver iodide contained in 100 cm cube of that particular saturated solution. So here AgIO3, this is plus and this is minus. Therefore, this is of the type, what is that? AB type. AB type means S is equal to directly root of what is P? KSP. Root of KSP. That is equal to root of what is KSP given? 1 into 10 to the power of minus 8. That is equal to 10 to the power of minus 4 mole per dm cube. The solubility is now expressed as standard what? Mole per dm cube. But here it is mentioned is mass per how much ml? 100 ml. That is equal to. How to convert mole to mass? 10 to the power of minus 4 into 283. Because what is 283 here? It is the molecular mass. Gram per dm cube. Gram per dm cube. What 283 is? It is the what mass? Molecular mass. We are converting mole to molecular mass, mole to mass by multiplying with a what mass? Molecular mass. That is equal to. But here it has for 100 ml. But here it is for 1000 cm cube. Therefore, 10 to the power of minus 4 into 218 divided by which one? 10 times. Why it is 10 times? Because for 1000 it is that much. For 100 it is divided by 10. So on simplification, 283 into 10 to the power of minus 5. Gram per 100 cm cube. Gram per 100 cm cube. So which is that simplification here? It is the 283 into 10 to the power of minus 5 can also be written as, I think this is correct, 2.83 into 10 to the power of minus 3 in terms of grams. For how much ml? It is for 100 ml. Okay. Let's move on to the question number 33. So here the tribasic acid, what's that? Tribasic acid. It furnishes how many type of anions? How many types of anions are present with respect to the what acid? The tribasic acid. Can I mention this as like this? It is an example for a what basic? Tribasic acid. First, it ionizes by the loss of proton to form H2A minus. H2A minus. Still, it further loses another molecule of another proton to form Ha2 minus. This further to form A3 minus by the loss of, means how many protons has lost here? 3. Means it contains 3 replaceable which one? H plus ions. Therefore, it is called as what acid? Tribasic acid. How many anions are this? This is first anion. This is second anion, and this is the third anion. Means it contains how many types of anions are there? It is H2A minus and then Ha2 minus and finally the A3 minus. Therefore, it furnishes totally the 3 anions. Okay. The solubility of which one? The solubility of lead hydroxide in water is given by how much? 6.7 into 10 to the power of minus 6 molar. Minus 6 molar. Its solubility in a buffer solution of pH of how much? 8 would be how much? So here first lead hydroxide. Can I say this? It is of the type AB2 type. It is of what type? AB2 type. So here KSP is given by first 4S cube, I think. 4 into S cube. That is equal to 4 into. What is the solubility given for this? 6.7 into 10 to the power of minus 6 whole cube. That is equal to 10 to the power of first minus 18. I will write this. Then we are having the 6.7 whole cube. First, what is 6.7 into 6.7? 49, 4. 42, 46. 42 here, 42 means 4, 36, 36 plus 4, that is equal to 40. Here it is 9, 8, 4, 4. 2 points means here, approximately I will mention that as 44.9. 44.9 into, what is 6.7 into 4? What is 6.7 into 4? 24, 24 plus 2.8, 26.8. 26.8 into 44.9. Assume that it is nearly equal to approximately, it is mentioned that it says 45 right now. Okay. 45 into 26.8. So let's have the 5 first. 4, 40 means 4, 30, 34, 4, 3 here, 10, 10 means 13 here, 4, 32, 3. So here it is 24, 24 means 27, 2. So here it is 8 plus 2, that is equal to 10. Here 0, 6, 0, 2, 1 I think. So here 1 point has to be removed here. Therefore it is 1 to how much? 0, 6. Means nearly 1200. It's equal to 1200 I think. 1200 into 10 to the power of what? Minus. Or I can write that as 1.2 into 10 to the power of minus 15 mole per dm cube. What is this first? The solubility. Sorry, not the solubility product. What is that? 1.2 into 10 to the power of minus 15. You have to work now because as if there is no alternates here. Okay. Now, lead hydroxide, we know that it gets ionized to form what and what? Pb2 plus how much? 2 times of what minus? Which minus? If this is the case, yes, this is yes, and this is also what? 2 yes. That is the solubility. Its a solubility in a buffer of pH is equal to 8 means. pH is equal to 8 means, what is pOH? It is 6. Therefore, what is OH minus? OH minus is going to be what? OH minus is going to be 10 to the power of minus 6. OH minus is equal to? We know that Ksp is equal to the product of the ions. What is the product of the ions? Pb2 plus into OH minus whole square. Therefore, what is Pb2 plus? It is Ksp divided by OH minus whole square. What is Ksp here first? Ksp is 1.2 into 10 to the power of minus 6 I think. Sorry, minus 15 I think. Divided by, what is OH minus? OH minus is 10 to the power of minus 6. OH minus square is 10 to the power of minus 12. On simplification, I will get that as 1.2 into 10 to the power of minus 3. What this is? Because Pb2 plus gives rise to what? PbOH twice gives rise to Pb2 plus 2. This is called as the solubility. Solubility is going to be how much? 1.2 into 10 to the power of minus 3. Therefore, this is the option. Means, as it is dissolved in a buffer of pH how much? 8. pH of buffer 8 means what is pOH? Automatically 6. If this be the case, what is OH minus directly? 10 to the power of minus 6. First, as it is a AB type electrolyte, we have calculated the value of what? Solubility product. But here we have to mention the solubility. Solubility is the concentration of the one of the ion. It is not solubility for the OH minus. So it is becoming actually 2s. But here it is, yes, solubility means it is the Ksp divided by what square? OH minus whole square. On simplification, we are getting the final expression as 1.2 into 10 to the power of minus 3. Okay. Let's move on to 35th. When ammonium chloride, what's that chloride here? It is ammonium chloride, is added to which solution? The ammonia solution. What ammonia solution is actually called? Ammonium hydroxide. Ammonium hydroxide itself is called as what? Ammonia solution. What is the pH of the resulting solution? NH4OH, this is called as NH3 plus H2O. This is called as what solution? Ammonia solution. Ammonia solution. How it is obtained? Just by adding the water. As if we know that it is a weak base, it gets partially ionized to form what and what ion? NH4 plus and then what ion? It's a weak base. To this we are adding the what chloride? Ammonium chloride. Ammonium chloride is a strong electrolyte containing NH4 plus as a what ion? Common ion. According to the common ion effect. If a strong electrolyte is added to the weak electrolyte containing the what ion? Common ion. The degree of dissociation of the weak base goes on decreasing. Means alpha goes on decreasing, that is due to the CIE. What is that CIE here? Common ion effect. Means OH minus concentration goes on decreasing, or H plus concentration goes on increasing, or pH goes on decreasing. Means pH gets decreased. It is indirectly the application of what effect? Common ion effect. Because we are adding a what electrolyte? Strong electrolyte. To the what electrolyte? Weak electrolyte. Both contain which ion? NH4 plus as a common ion. First, the degree of dissociation goes on decreasing. As the degree of dissociation decreases means NH4 plus as well as OH minus also decrease. As OH minus decreases means H plus concentration increases such that the pH also gets decreased. Okay. Next, a rapid change of pH. A rapid change in the what? pH. Near the stoichiometric point is also called as end point of an acid-base titration is the basis for the indicator detection. It's one of the principle of which one? Volumetric analysis, where we are detecting the what point? End point by the addition of a suitable which one? Indicator. Here the indicator is acid-base. The pH of the solution is related to the ratio of the concentration of the conjugate acid, that is called as HIN, and its base, that is called as IN minus, forms the indicator given by the expression. What is that? So here HIN indicator, acid base indicator here, it ionizes partially to form H++ IN minus. Now, what is the value of which and which here? It is the, taking the equilibrium constant K is equal to, it is a H plus concentration into IN minus concentration divided by HN. What is H plus concentration is equal to here? It is equal to K into HIN divided by IN minus. Compare with respect to this. H plus concentration, we know that it is equal to K into the acid concentration divided by salt concentration. Observe the value, same. What's that? For which buffer? Acidic buffer. As we have derived one equation called as Henderson's Esselbach equation. H plus concentration is equal to K into acid concentration divided by salt. What's the pH we have derived for that? pKa plus log base 10 of salt by acid. Salt by acid. Now, instead of this I will put pH. Instead of K I will put here, what is the symbol that has been given? pKin plus log base 10 of, which is salt, and this is, which is the acid here. This is acid and this is acid and this is salt. Acid and salt. Then log of what by what? Salt by acid. Salt by acid is IN minus divided by HIN. So in what format it is given? Let's have that. What is log of IN minus divided by HIN? Right now, shift here. pH minus pKin. So here the log of, this is actually the salt. This is actually the acid. Log of salt by acid is equal to what minus what? pH minus pK. Instead of pK it is pKin. Means it is the equilibrium constant for the indicator. That is acid base indicator. So where we are observing here, IN divided by HIN. IN divided by HIN is pH. No, these two A and B gets cancelled. So I think it is HIN divided by IN minus divided by HIN. Therefore the option with respect to this is, it is the D. Means it is observed in case of a what indicator? Acid base indicator. Acid base indicator is given by HIN is gives rise to what plus what? H plus IN minus. Observe with respect to the similarity of the acidic buffer, as if it gets ionized partially. According to that, it is H plus is equal to K into acid by salt, or on simplification or derivation we are getting the final expression as pH is equal to pKa plus log based on what by what? Salt by acid. Put the value of salt and acid concentrations instead of HIN, or it may be the IN minus, and instead of pKa we are mentioning the what? pKin. Okay. So let's move on to the 37th. Now, an amount of solid ammonium bisulfide, NH4HS is called as ammonium bisulfide, is placed in a flask already containing ammonia gas at a certain temperature and 0.5 in terms of atmospheric pressure. Ammonium hydrogen sulfide decomposed to yield ammonia and then the H2 in the form of H2S in the form of gases in that flask. When the decomposition reaction reaches equilibrium, the total pressure in that particular flask rises to how much? 0.84. Initially it is already 0.5 because it already contains the ammonia gas of 0.5, but after attaining the equilibrium by heating to a certain temperature, its value becomes how much? 0.84. Then what is the equilibrium constant for ammonium bisulfide decomposition at this particular temperature? So here NH4HS of solid state is in equilibrium with what? NH3 gas plus H2S gas. This is the equilibrium that has been obtained. Initially, let's suppose that it is 1. Here it is 0.5 in terms of ATM. Here it is 0 because ammonia is already present in the form of how much atmosphere? 0.5 atmosphere. Okay. Now, let X be this one. I don't know about that. How much it gets decomposed. If this be the case, this is X and this is also what? X, because they are in the ratio of 1:1:1. What is left here? 1 minus X, 0.5 plus X here. It is going to be the plus X. So here, the P total is given by 1 minus X plus 0.5 plus X is equal to 0.84. Means the total pressure when it attains the equilibrium is found to be the how much? 0.84. So I will cancel these two. 1.5 I think. 1.5 plus X is equal to 0.84 or X is equal to how much? 1 minus X plus 0.5 plus X, that is equal to these two X gets cancelled. 1.5 here, 1.5 plus X is equal to 0.84. Therefore 1.5 plus X is equal to 0.84 means X is equal to 1.5 minus 0.84, that is equal to what's that? 16 plus 5, 74 I think. 0.17, sorry. 1 minus X here, it is 0. So as it is a pressure, it doesn't have this. Why? Because it is a solid state. Therefore I am neglecting this one. 0.5 plus 2X is equal to, because why I am not included here, this one is because as it is in a solid, we can't expect the pressure with respect to the solid substance. That is why we are neglecting this. Okay. Therefore 2X is equal to 0.84 minus 0.5, that is equal to 0.34, or X is equal to what? 0.17. What X is? 0.17. Therefore what is the partial pressure of ammonia here? 0.5 plus X, that is equal to 0.67. What is the partial pressure of H2S? That is equal to X. X is means 0.17. What is Kp expression for that? Kp is equal to only partial pressure of ammonia into partial pressure of H2S divided by not this. Why? Because it is a what? Solid. Because the partial pressure for only the gaseous but not the solid, or it may be the liquid. So just the multiplication of these two. Ammonia is 0.67 into 0.17. So approximately I think it is 0. We have to calculate in particular. 0.67 into 0.17. 7 sevens are 49 here. 7 6 are 42, 46. So 1 is here 67. Here it is 9. Here it is 3. Here it is 11 I think. So 2 plus 2, 0.11. 0.1. So here we are neglecting the pressure with respect to the solid substance called as ammonium bisulfite and considering only the partial pressures of ammonia and then the H2S. But initially actually all the products will have the 0, but already it is given as how much atmosphere? 0.5 atmosphere with respect to only the ammonia but not the H2S. Based on that, the total pressure is going to be 0.86. Here 0.5 plus X is equal to 0.84. On simplification, I will get the value of X is equal to how much? 0.17. Then substituting the values of those, we are getting the final expression for Kp, and that Kp is called as what constant? Equilibrium constant for the decomposition of what sulfide? Ammonium sulfide. Okay. Let's move on to 38 right now. For the precipitation of which one? The second group cations, only the solution is made acidic. Why? Second group basic radicals, fourth group basic radicals. So here taking original solution plus H2S plus HCl. Here we are taking original solution plus ammonium chloride plus ammonium hydroxide plus HCl, H2S. These are group reagents. Here this is having the sulfide concentration, this is also having the sulfide concentration, and this is going to be the less and this is going to be the more. Because due to the common ion effect, we are maintaining the what medium here? Acidic medium. That acidic medium with low concentration helps for the precipitation of only the what group basic radicals? Second group. Similarly, due to the common ion effect, first the OH minus concentration, but it increases the concentration of sulfide because common ion effect along with the Le-Chatelet's principle makes the what nature? Basic nature, and that basic nature helps for the precipitation of what groups? Only the fourth groups. As if it is a second group here, cations. Cations are also called as what radicals? Basic radicals. The solution is made acidic. Why? Because to decrease or increase the sulfide concentration. To decrease the sulfide concentration. Similarly, you have to remember for the what group? Third group. Basic radicals. OS plus NH4Cl plus NH4OH. Here we are maintaining the OH minus concentration of less due to the what? Again we are maintaining the what medium? Basic medium, and that is helpful for the precipitation of only the what groups? Third group basic radicals. Second is a sulfide of low concentration acidic. Fourth group is again sulfide of higher concentration but of basic, whereas the third group radicals are precipitated as the respective hydroxide, which is found to be the what medium? Basic medium, and that helps for the precipitation of what group? Fourth group basic radicals. Basic radicals are also called by another name. It is called as cations. Okay. Let's move on to 39 right now. What's the 39 here? The composition of an acidic buffer mixture of HA and NaX is found to be having the total molarity of 0.29, having a pH of how much and how much? 4.4, and K is equal to 1.8 into 10 to the power of minus 5. Assume that HA is acid, let it be X. Then another one is NaX, that is found to be the salt. Let us found to be the 0.29 minus X. Why? Because the total mixture of A plus S is equal to 0.29. It is given. That you have to remember first. The mixture of which and which? HA and NX. I will mention that in the form of A and S is found to be 0.29. If the total is 0.9, let the concentration of acid is found to be the X. Therefore, the salt concentration is how much? 0.29 minus X. And also, pK is equal to negative log of K, and you have to be very familiar with this particular value. That is 1.8 into the power of minus 5. That is equal to 5 minus log. Log 1.8 is, we have solved so much problems related to this. That is equal to 4.4553. That is equal to 4.7447. 4773. Nearly 4.8 or 4.7447 is the final case. Okay, assume that it is nearly equal to 4.75. Okay, we check the values with respect to log 4 and then log 5. Based on that, we will get to the value of 4.75. Therefore, for acidic buffer, AB buffer, what's the expression? Directly I will write that as pH minus pK, pH minus pK, pH is equal to pK plus log based on what by what? Salt by acid. Okay. So here pH is greater or pK is greater here? pH is how much? 4.4 and pK is 4.74. Therefore, what is pKa minus pH? That is equal to, what is 4.4? 4.75 minus 4. This one. That is equal to 0.35, I think. 0.35, and that is equal to log of based on what by what? Salt by acid. Therefore, what is log salt by acid? Anti-log of 0.35. Anti-log of 0.35. How to get the value of anti-log of this? First, we know that log 2 is 0.3, log 3 is 0.48. We need anti-log of 0.35. 0.35 is somewhere here. Means I am getting around 0.24 or log 2.4 or 2.3, whatever it may be nearest. Okay, that is 2.4. What is 2.4 here? It is the antilog of 0.35. Okay. It's not exactly that. 2.5 means 0.39. 0.39 means it is approximately 0.23. Let us assume that as 2.3. Okay. So therefore, S by A is equal to, S by A is equal to that. Therefore, what is S? S means it is, S is 0.29 minus X divided by X is equal to 2.3. 2.3X is equal to, or directly on simplification, plus X is equal to 0.29. 3.3X is equal to 0.29, or X is equal to 0.29 divided by 3.3. It is nearly 1 by 11. 1 by 11 is nearly equal to 0.09 molar. What is here? X. What is X here? It is the acid concentration. Here salt and acid is given. So salt and acid is given. The salt is found to be how much? If this X is, what is this? X means it is A. Acid concentration is actually how much? 0.09 molar. Therefore, what is salt concentration? 0.29 minus X. 0.29 minus means it is 0.20 molar. So here as mentioned the salt and acid. Salt and acid is 0.2 and then 0.09. Therefore, it is found to be the B. Okay. So here the one condition that has been given, the mixture of the molarity of both the salt and acid is given as how much? 0.29. We are assuming acid is found to be the X and then the salt is found to be 0.29X. And simplification with respect to what? The Henderson's equation, that is pH is equal to what? pKa plus log base 10 of what by what? Salt by acid. Okay. So 39B here. pK minus, sorry, it's actually pK minus this one is actually log of A by S, sorry, A by S, sorry, A by S. Therefore, it is just a reciprocate of that, that's it. It is found to be the A but not the B. So it is the A option. Okay, you have to take the option A with respect to question number 39, because as if it is not pH minus pK, it is pK minus this one, means it is log of A by S. Initially I have taken that as log of salt by acid. Okay, so 39 it is bound to be the A. Next, 40th. The degree of which one? Hydrolysis of a salt of a which and a which? Weak acid and a weak base in its 0.1 molar solution is found to be how much percent? Just only 50%. Suppose if the molarity of 0.2 molar, solution is 0.2 molar, then the percentage of hydrolysis of that particular salt would be. Salt of weak acid, strong base, weak base, strong acid, weak acid, weak base, strong acid, strong base. So here these two are independent upon the concentration and these two are dependent upon the concentration. So as if it is a salt of a what and a what? Weak acid and weak base. The degree of hydrolysis is independent upon which one? Concentration. Even if it is of 0.1 molar, if it is 50%, means for 0.2 molar, it is also how much percent? Because the degree of hydrolysis for a which and a which? Either a weak acid and a weak base, or strong acid and a strong base is independent upon the concentration. Therefore, it remains the same as that of the original. Okay, it is 40B. Next is given a complex, what is that? AgNH3 twice of plus gives rise to AgNH3 plus NH3. K1 is given. AgNH3 plus gives rise to Ag plus NH3 gives rise to what? NH3. K2 is that much. The instability constant for the complex AgNH3 twice plus is equal to how much? AgNH3 how much? Twice of plus is equilibrium with AgNH3 plus NH3. Similarly, another one is, this is K1 naught. AgNH3 plus gives rise to Ag plus NH3. Here the equilibrium constant is K2. Okay? If I add these two such that I can cancel these two, AgNH3 how much? Twice gives rise to Ag plus 2 times of NH3. This is the equilibrium constant, but this is called as instability constant, and this is called as stability constant, or it is also called as formation constant. As it gets dissociation means it is unstable. As it is formation means it is stable. But here he has mentioned the what? Instability constant. So here K instability we know that it is equal to K1 naught into K2 naught. Why? Because as if we have added, the individual step is equal to what? The product. Okay? What is K1 naught? 1.4 10 to the power of minus 4 into, this one is 4.3 into 10 to the power of minus 4. That's equal to 10 to the power of minus 8 plus. What is 4.3 into 1.4? 14 3s are 42. 14 4s are 56. 56 means it is 60. 60 means 1, 2. Here it is 6. 6.02 into 10 to the power of minus 8. Therefore, it is going to be the C. Okay. So, this is called as what? The instability constant. Suppose if as the stability constant means it is just the reciprocate of that. It is 1 upon K1 into K2. Okay. We'll move on to the last. What's that? In that particular reaction, what is that? 2x of gas plus y times of gas gives rise to 2 times of Z gas plus 80 kilocalories. Which combination of pressure and temperature will give the highest yield of this? Highest yield of Z means it is forward reaction. What forward reaction is? So this can also be mentioned in the form of delta H is equal to minus 80 kilocalories. Either we can write products plus energy or delta H is equal to negative. Means it is what thermic? Exothermic. Then what is the value of delta Ng here? It is 2 minus 2 plus 1, that is equal to minus 1. As it is exothermic means it has to be carried out at low temperature. It has to be carried out at low temperature. As delta Ng is negative means it has to be carried out at high pressure. Observe the conditions which suit for this. Means we have to observe only the low temperature and then the high pressure. Among that one, the low temperature is 100 degrees Celsius. I can select in the form of C and D. In addition to that, the pressure must be very high. Among those two, which is the pressure here? There D it is 500, here it is going to be the C. Therefore, it is going to be the C option. Because as if the formation or the yield of Z is nothing but a what reaction? Forward reaction. Here the forward reaction is an example for a what thermic? Exothermic. Exothermic are always carried out at what temperatures? Low temperatures. In addition to that, the value of delta Ng for the forward reaction is going to be minus 1. There is a decrease in the number of moles means the volume is less. As the volume is less means the pressure has to be high. Means this reaction has to be carried out at a higher pressure followed by the what temperature? Lower temperature to get the maximum yield of which one? Set. Okay, that is C. Okay. So I think this totally completes the one of the most physical topic related to the class 11, that is first PUC, that is called as equilibrium. So here it is purely based on the mathematical concept, because as if we are having a pH, pOH, Ka, Kb, pKa, pKb, H plus OH minus buffer concept, solubility and solubility product. Okay, then the H plus concentration based on K and then C, or it may be the NC alpha, and then the OH minus is also equal to NC alpha. Means all these are purely on the mathematical concept. In addition to that, as if we are having the P concept that is called as a negative logarithm, you have to have the very fine concept of the log starting from 1 to 10, and the reciprocate of that we will get in the form of which one? The anti-logarithm. Okay, so for that you have to be very familiar with respect to the which one? The physical formulas, or the formulas related to the what? Equilibrium. Okay, so this totally completes the one of the most important topic for physical chemistry for first PUC, that is called as equilibrium. Okay, so thank you.